1.
For regression equations, we have 4 definitions. The first definition is regression equation, and that's an equation that the calculator creates that represents the line of best fit for a given polynomial. We have the definition of a scatter plot, which is a series of plotted points on a coordinate plane. Correlation coefficient is the R value, which indicates how accurate the line of best fit is. And you want that value to be the closest to 1 that it could possibly be, and that includes 1. 1 would be the best correlation. Superimposed is telling the calculator to graph the regression equation over the scatter plot. So it will put your equation into y1, it will graph your points in scatter plot form, and then it will also graph the regression equation as well. Your very important concepts. So these are your steps to finding a regression equation on your calculator. Step 1, you're going to push the button Stat, Edit, and in L1 you're going to enter all the X values, and in L2 you're going to enter all the Y values. Remember, if you need to clear L1 or L2, you can scroll up, hit clear, and scroll down, and it should clear out the whole column. You enter one number in at a time, you enter the number, then hit enter, and they should all come in L1 and L2. Step 2, you want to make sure your diagnostics are on. So you're going to hit second 0 and scroll all the way down to diagnostics on and hit enter. And that'll turn your diagnostics on, which will make the correlation coefficient show up when you get your equation. Step 3, you're going to hit Stat, Calc, and choose the appropriate regression model. The ones we use the most are linreg, quadreg, and cubereg. Linreg is your linear regression, so that's an equation such as y equals mx plus b. Quadreg is a quadratic regression, so you have something like y equals ax squared plus bx plus c. And cubereg is cubic regression, so you have ax cubed plus bx squared plus cx plus d. Step 4 is to superimpose your graph over your regression that you got, so you're going to click the button vars, y-vars, function, and y1, and that'll put the equation right into y1 for your calculator, so that when you hit graph, you have that there. And step 5 goes back to step 3. Once you pick which one you have, and you hit enter, you're going to have the equation. So right here, this is if you hit linreg, and you have the equation y equals ax plus b, a equals 7, b equals -5, and r equals 1. So your equation would say y equals 7x minus 5, and it has a strong correlation coefficient since r equals 1. So here's an example. It says find the regression equation that best represents the data and superimpose the graph. So in L1, all my x values, -2, -1, 0, 1, and 1, 2, and 3. I'm going to do stat edit and enter all those values into L1. In L2, I'm going to enter 4, 0, -2, -2, 0, and 4, and make sure all those values are in L2. Then I'm going to click stat, calc, reg, vars, y-vars, function, y1 to get that equation into y1. We're going to do it for a linear regression, quadratic regression, and cubic regression to see which one is the best fit for this set of data points. If you were to do a linear regression, you would get that A with these data points. You would get that A equals 0, B equals 0.666666667, and R equals 0. Because this value is R equals 0, and that's your correlation coefficient, you know that this is not the best fit line since it's very far from 1. Your equation here would be y equals 0, x plus 0.6666667. Your quadratic regression, you would get A equals 1, B equals -1, C equals -2, and your R squared value equals 1. Because your correlation coefficient is 1, this is a very good model for this data, very good line for this data. Your equation would say y equals x squared minus x minus 2. For cubic regression, you would get a equals 0, b equals 1, c equals -1, d equals -2, and your r squared value would also be 1, but when you went to go write this as an equation, you would get y equals 0x cubed plus x squared minus x minus 2, and because this is 0x cubed, it really is a quadratic equation because your first term, that's a real term, is this x squared, so it's the same thing as over here.